Thank you.
Okay, great. Okay, thank you for your invitation. Okay, dear everyone, my name is Jie Dou from the China University of Geoscience. My major focus use AI for the prediction for the predicting the geohazard. So today I would like to give the topic about the use and the advancing reservoir landslide stability assessment while the Multi-SAR and Airborne the LiDAR observation based on the numerical simulation. I mean, a case study in the Three Gorges Dam area in China. So we also this paper we published in this the Lancet in the Lancet journal in this year. Maybe if you want to know the details, maybe you can read this and the reference. Okay, let's. Before my start to my talk, I would like to give just introduce my group and for the research direction. As I mean, in my group, I'm charging our team. So in my group, we have the three topics. The first, we use AI based on the geo disaster identification. So we use like optical and SAR and all the LiDAR data for the landslide or geohazard in automatic detection. After detection the geohazard, so we use AI for the multi-scale and the hazard assessment, and for the for the like the potential or for the large scale for the geohazard. So we try to use the simulation and the lab test for exposure and the maximum of the geohazard, and for the potential geohazard. So we try to install the sensor to build the IoT order and the cloud platform for the monitor and do the earning system. Okay, this is about my main direction. Okay, let's start to my research. My research includes the five parts. The first, introduction. As you know, I mean, like the world order. First, I was staying in Japan around 10 years. Also, I mean, like in Japan, China, we serve the huge losses due to the landslide disaster every year. And China, and also it country with the most the frequent the landslide disaster in the world. So as for and may you know, and the Three Gorges Dam along Yangtze River in China, and the back of the landslide have then the risk of the water distribution and large the volume and more complex the structure and the serious the harm. So this figure shows that the serious, I mean, some of the very typical, and the reservoir triggered the landslide. And this is shown the combination of the hazard in China and distributing the map of the typical back the landslide in the Three Gorges Dam area in China. And we also in areas with the complex and the topography and the geomorphology, traditional and I mean and the manual surveys are less than sufficient remote sensing technology what used for the early identification and monitoring of geohazard, many include the like the optical remote sensing and InSAR and UV. So and also the LiDAR the LiDAR like they use the LiDAR data. And as we know, that traditional field geohazard survey technology in the process and the obtaining and the topographic data is very difficult. Also, it's very dangerous, and with which limited and identification and analysis of the geomorphological feature in area with the dense vegetation. Optical imaging can be used to identify the landslide hazard in advance based on the difference in color tone and the text of the image of the suitable resolution. So also the UV the light data is the camera of the high accurate ground information through the multiple echoes through the highly vegetation areas. And the landslide prediction criteria are one of the indicators used to determine that the slope body has entered in a state of the critical instability. So my story and when we know the different algorithm across different measure point depend on the scanning the mix of the SAR, like the sparse SAR and TS-SAR and DS-SAR. And we combine the spectral coherence and amplitude dispersion index threshold to select the PS point, and the spectral coherence analysis was used to identify the pixel with the low spectral phases diversity, from which those and smaller the phases and different variation was selected at the PS point. Also, the amplitude of the threshold was also used to select the pixel with high amplitude values, from which those with smaller amplitude dispersion values were determined as the PS point by combining the PS point from the two different approaches mentioned above. So this final PS point was averting, and they were assumed with stable radar scanning characteristics, thereby enhancing the accuracy of the subsequent time series display analysis. And due to the similarity and the uniformity of the distributed scatters, multi-looking enable averaging of neighbor pixel, so thereby reduce the noise and emphasizing their consistent spatial distribution and characteristics. Subsequently, candidate point targets were identified based on the low temporal availability of the SLC in testing after multi-looking. So then we also apply for the maximum the likelihood estimated MLE to the multi-looking complex normalized intergraphing and the corresponding back scatter in testing imaged with the 32 by 32 move window for each time point to estimate the degree of the spatial coherence. So when a uniform weighting of the back scanning in testing imaging allowed us to obtain the spatial coherence estimate. So we can continue the annual mean values of the spatial coherence for each pixel in an topography point targets with the coherence above the 0.3 designed at this point. So we combine, note each method are perfect. So we combine PS and DS point. So we effectively address the issue of insufficient MPS density associated with the traditional PS-SAR method. The information phrase of the combined MPS was distinguished and contained and then unwrapped. So through the algorithm competition and regression analysis, the linear displacement, elevation, the residues, and other residues, the phases were computed separately. So in the spherical dam, the significant water vapor also evaluation occur, and the removal of the elevation related to the atmospheric phase using DM greatly can improve the efficiency of the time series analysis. So further to isolate the anomaly adjustment, atmospheric delay physics and noise physics component, multiple frequency domain filter the technique were applied, and consider the specific and the characteristics of the residual phases in both the temporal and spatial domain. Finally, the displacement rate and accumulated displacement during the study period were got. So this is a comprehensive approach ensure an accurate and reliable measurement of the ground displacement and provide the valuable insight into the advancement there. So this is a plot of the how to collect the data for the UAV. So first we can use the UAV and analyze the data to and then get it. We do the data analysis. Then we try to make the DM utilizing and use the 3D for the numerical simulation. And finally, we do the slope for the slope feature detection and do the slope assessment, slope stability assessment. So there's a remote sensing from a UAV. So UAV tilt photography and UAV carries the LiDAR technology to achieve a very comprehensive remote sensing for the land side and with complement and advantage. to provide us scientific ideas and the reference for the comprehensive and the refined information extraction and rapid stability analysis of the Razorback unless under the radiation cover. And this show out the group we bought the different UAV. The UAV is always the high resolution digital camera and with GPS and navigator and remote controller and automatic altitude and speed measurement device to obtain under the comprehensive spatial 3D information by means of the aerial survey. The high resolution image can be acquired at a low tilt advantage point and high rotation and angle changes. So on broader receiver, we real-time monitor the presence and no need to lay the ground control point GCP. So came out the acquire the high or fine resolution digital service model and digital orograph. This figure shows the last year we went to the back the reservoir. So we do under the we get a different data. And also this is the LiDAR. LiDAR is a very active remote sensing technology that used for the laser for the detection and measurement. It combines the three technology of the scanning laser, refined data, red finder, global GPS, global position system, and interior measurement united into the mapping the system. And it can directly penetrate the high vegetation area through the multiple echo to the high accurate 3D ground information and generate the 3D model. Because in the street draw diamond, so there are the area was fully covered by the vegetation. So we use LiDAR is very useful. And this is the multiple appearance DM, but were collected from the our quantum port lens in the street garden. We use a different camera. So rather than compare this one, this is fine. And this is a show of the emission shows of the bottom test site. So we dig the tunnel in along the base of and the rock base of the last side. We do different than the multi observation to monitor the landslide. And this there are 6 parts though. I mean for the data and the collection and we do under the field work and start survey, deployment of inspection and collect the special coordinates of the inspection point, drawing installation and calibration check, and routing planning and parameter setting and drone data collection to verify whether the accuracy of the imaging control-free UAV survey technology meets and the specific requirements. So totally around 20 GCP point were used to check at the checkpoint to verify the accuracy of our post product the maps. The next after we getting data, so the ground point produced by the UAV the LiDAR data. So we come on to the in test and for the format, and we generate a survey model based on the row operation to the color the rectangle, so it unites with the survey model. So we delete them upon the redundant part when after the completion of the card to the produce as a simple 3D solid model combined with the draining data can achieve a laying effect. So next, we based on the DM on the topographic data and the geological survey data, a multiple layer 3D geological model is established. So Flag 3D can accurately simulate the mechanical behavior of the damage or the classical flow of the geological material when they reach the strength limit of all the year the limit. And is especially suitable for the analysis of progressive damage, instability, and the simulation of large deformation. And the case study. So our case study means we call the landslide Daping the landslide group. This is the landslide group is the series on north bank of the Yangtze River, Yangtze River in Badong County, about 3 kilometers from the center of the Badong. And the 6 kilometer from the Three Gorges. This is Three Gorges Dam. This is the largest dam in the world, and the Sunlight Manual Sentinel data for the past 84 provide completely covered this study area, which is then predominantly mountain area and had high elevation difference, and the landslide group span the length of around the 1,000 around 2,000 meters and reached a high around 500 over the 500 meters. Comprising the multiple slope with the overturned shape and the platform. The slide surface is folded with an steep slope in the middle or the gentle slope at the bottom. And the average slope angle is about 35 degrees, and the aerial steps of slide is about 45 meters. So, and this shows the light data, how can the light data. So we first we do we before the flight preparation we need to do DSM and with the DJI M300 RTK, and then we use the UV assistant data acquisition, and we get the ground imitation flight and do the data reception UV, and we wire flight control and data validation. And then if we get the UV data, we will do the raw data processing. And we use that, we get that manual point the data, and we need to do the point, the classification, and then after that do the calculation, we get the 3D model and the high resolution of DM. This flow chart shows the point data acquisition and processing. So finally, we compile totally around 69 settings in one image to derive deformation history of Daping the group and spanning from around 2 years. And this shows the result. So the slope is divided into the 4 blocks, block L1, L2, L3, L4, and marked by the yellow boundary. So block L1 and then L1 has the largest displacement rate with annual average maximum displacement is around 16 millimeters per year. And the block L2 has the smallest number of measurements with an annual emergent displacement rate of around 15 millimeters per year. And block L3 and L4 so have a dense distribution of surface measurement point and a more uniform distribution of displacement rates, with the maximum area of displacement rate being over 14 millimeters per year. So the whole deformation show a gradual decrease from the west to east. So then the overall deformation shows a decreasing trend from the west to east, and also we can see our data and with the GPS data and show with a very high relationship with an R square around 0.7. And this is the validation in area 3, and we collect around 341 DSR and around 200 PSR. So under increased density, this in each block was set and for the time series analysis to understand the panel surface change in the slide area. At the times of the 20 point at different special location means filtering was used to optimize the final time series result and weaken the effect of the error on the result, so that the displacement was mainly located in the west part of the landslide, and with the largest displacement at the top and face of the slope, flatter displacement at the foot of the slope, and a more stable slope above than the block compared to L1 to 4. And this figure shows, the displacement of Daping or this landslide group, so it's very close. Is close related to the fluctuation in the reservoir level and rainfall. Monitoring, and then there is a very high series effect between the displacement and the water the level fluctuation. So for the tow point during the period I, as the reservoir water level drops and the distribution of pore water pressure with the landslide mass lags, generating the hydrodynamic pressure. And conversely, when the rise in the water, when the rise the water level, alter soil saturation, reduce the shear strength, and the effect and stability of the starting the mass, leading to the increased displacement during the period 2, and this and the displacement of the rear 8 point is more significantly influenced by the rainfall during the period 3. So conditions of the rainfall cause the accumulated displacement at the rain reach point to reach and minus 15.4 millimeter with the water level change have the relative minor impact. And this is data from where this analysis is elevation information from the LiDAR data. And from this figure, we can that this the group, the Daping the Landslides group has the relative fragmented surface and it covers with the dense with the vegetation to reduce the impact of the single and the light source on DM emitted visualization and sky wave factor SVF was used through the visualization and let's say the DM. It can overcome the loss of the slope details caused by the lighting. And SVF emitted not only clear display the boundary of the landslide and the gully, we can see the gully and boundary, but also can more clearly show than the subordinate topographic features than the hill shading, such as the landslide, the clouds, we can see the landslide and the clouds area, and the characteristic slope that is low in the middle and high in both sides. So the longitudinal profile CC of the L2 area show that the slope is very steep at the top and the gentle at the bottom. On the left side, on the left side and from the edge, so there is the crevice of the back from the perspective and morphology. So this is the topographic structure affect and stability of the slope. And this the hydroflagration belt area is affected by the scale of the reservoir water level, characterized by the crisscross pattern of the gullies and high in incidence of the geological disaster, particularly the back and collapse. Back collapse not only lead to the soil erosion, but also the deterioration of the geological environment, but also continuously exhibit of the destruction of the back slope and can even trigger the reaction of the landslide. By utilizing the long-term remote sensing data to study the degree of the vegetation recovery in the hydro fluctuation belt area, so it's possible to quantitatively analyze the impact of the water level changes on the hydro fluctuation belt, and can explore the erosion condition and the front edge of the landslide. So we use the days and the landslide time series from around 30 years data to investigate from 1919 to 2020, around 30 years, to investigate the impact of the reservoir water level change on the landslide slope, with a particular force on the development of the back slope. So during the period of low water level, there is a certain degree of vegetation recovery in the hydroflagration belt. However, the vegetation recovery is relatively poor in the area fed by the back collapse. By comparing the anywhere of the area after the impoundment of the T-3 dam and assessment of the vegetation recovery, the timing of the back collapse can be determined. So in 2010, after the GR reached the water level of the 175 meters, so vegetation recovery at this point was relatively poor. And this show our the landslide distributed by the numerical simulation. And the simulation, the validation was continue than the flow solid combine and the large and the displacement occur during the period the reservoir level drawn down, and the maximum displacement was observed as the up part of the slope, while the tool show than the smaller displacement. So the GPS the result also shows a similar trait to our simulation result. So the simulation result at the low part was smaller. And both nature and high manufacture contribute to the landslide evolution. So this study summarizes that the evolution, the characteristic of Daping group from the spawn-borne, airborne, and ground-borne, and and the spare air ground integrate the landslide moist area, and we can see that the rock, the blending deformation, and the fragmentation, and for formation and contaction of the starting surface. So T2 stage increase the slope displacement and crashing due to the reservoir water and rainfall. And with and conclusion. So there are no each method is perfect. So we combine the DS and the PSR or effect to use increase and density of MPS in TS-InSAR. And our result also combine with the real domain data, and we get the high correlation and combine with the InSAR series with the reservoir water level and reinforce stress and the stability of slope from the aid is primarily influenced by the fluctuation in the reservoir water level. And we also use the SVF and the embedded derived from the LiDAR DM micro geographical feature on the landslide surface can be clear and defined. So we do the auto future prospect for the intelligence of the landslide identification. So I think and we know that geohazard is very hard to predict. So in the future, we consider AI combine the big data and also the geohazard monitoring and for the animal sim and in deep integration can provide our new idea for the disaster reduction and prevention, such as in this year, physical and the Nobel Prize and chemistry, the Nobel Prize also they give the AI the field. So AI I think can also provide a very useful tool for our geohazard. So we combine the features and parameters, algorithm, and machine learning and the physical model geohazard, and we can mitigate and do another prediction. And we may know for the AI for the geohazard, this is the kind of blank box. We need to know the gray box or the white box can explain for explain and the AI how this works. So we need to multi-field the cooperation monitoring. We combine the different and the field for the landslide handler observation technology. And finally, in our COD training geoscience, we also issued two journals, the Journal of Earth Science. So this is impact for over the 4.1 belong to the Q1. So if you are interested, welcome to submit this journal. And in this journal, we also issue and special issue, and the special issue and the evolution of the maximum of the prediction of the water-induced geohazard. So this special will be closed at end of this year. So if you are interested, so welcome to submit, and we can publish this journal earlier because we can give the priority to deal with this journal. And also we try to introduce some of the work. Our group we do the landslide detection, and this video show how to use AI method, try to automatic detection and for the landslide. This lecture, this video can teach you how to do landslide step by step. So if you are interested, So maybe you can, later you can search out some of the GitHub or some other lecture or some we put in our public and the code. Because time is very limited, so I just show you. This is show you how to do automatic detect the landslide. And we also do, we also developed some of the software. We developed some software for the company. This year we do the operation of the interface of the system is divided to the later show them the login interface and main and operation, and we use then the LiDAR and optical and the for the landslide crash detection. And in this year we also developed and some sorry, this is in Chinese. We developed and digital twin system for the geohazard and the prediction. We use the big data, use some AI, and we try to we use the numerical simulation and combine with the basic threshold. And finally, we built then the first in the world, in the street called the Reservoir Area. This is the first domestic and international large scale field comprehensive research and testing site with an internal complex as the main body, and the integration of the space air ground deep have been built to carry out scientific experiment and monitoring. We have an over 10 years of the field data on the landslide. The evolution have been collected. So if you are interested, welcome to Without University, so we can do some of the collaboration. Finally, so if you are interested, and maybe welcome the master PhD student, we can provide the scholarship. We can provide some of the funding for the postdoc or even the excellent research to join us. If you are interested, maybe you can scan the barcode. Maybe we have some of the many lecture, some of the materials, and for the study for the connection. Maybe you are welcome to contact us. Okay, thank you for your time.